In the chapters for circular measure, there is 2 units that you need to take out of. One is the radian, and then the other one is the degree. So the relationship between radian and degree is like this. So pi radians is 180 degrees and 1 radian is 180 degrees over pi. So which also means 1 degree is pi over 180 radians. So this is usually used for conversion of units. Then we have this section about area of sector and arc length. So there are two types of units, so there are 2 different formulas. So one is this one for area of sector, which is in degree, and the second one is in radian. And the arc length, which is this portion, is defined by 2 formulas also. One which is this one in degree and the other in radian. So depending on the question and the units, you will choose the formulas accordingly. So then there is this area of segment. This is a segment. So the segment, how to find the segment would be to use the area of the sector minus subtract the area of the triangle. So area of triangle is given by the formula half AB sine C. So in this case, A and B is this and C is this angle. So it will be half R square sine theta. Then area of sector will be half R square theta as before. So you get this. Now there's really no need to memorize this formula unless you have no choice. But by common sense, you will be able to sort out the area of segment pretty easily. So this is our first question. So we have ABCD is a square and BC is 2R. Then E, F, G, H are midpoints, so that means here is R and here is R. So we have E, F, G, which is this, it's a semicircle with center O. We have another arc sector, which is this EG, and it has a center of H. So then HG is root 2R. Then they are looking for which fraction of the square is not shaped. So what we can do is we will find this section, then we subtract off this section to find that shaded one. Then from there we can find the unshaded. So I would first find the area of square equals to 2R squared, so it's 4R squared. Then we will find area of the quarter circle, EGH will be 1/4 times pi times R square, the radius is root 2. Then we will find the area of triangle AGH, which is half times A B sine C. So it will give you So the area EGO will be quadrant half pi r squared minus the triangle, which is this. Then the shaded area in the diagram will be the area of semicircle, which is half pi r squared minus r squared. So the unshaded area will be 4r squared minus r squared equals to 3r squared. So the fraction will be 3r squared over total 4r squared equals to 3/4. Second question over here is made up of two sectors, one which is the major sector and one which is the minor. So this is the major sector, this is the minor sector. So the question says that the perimeter of the major sector here is twice the perimeter of the minor sector. So that's where we start. So perimeter of major sector equals to 2 times perimeter of the minor. So perimeter of the major sector will be r theta, but theta over here will be 2 pi minus theta. R theta plus 2r equals to 2 times r theta plus 2r. So then we'll simplify 2 pi r minus r theta plus 2r equals to 2r theta plus 4r. So 2 pi r so we want theta down here, so we have 2 pi r plus 2r minus 4r equals to 2r theta plus r theta. So it's 2 pi r minus 2r equals to 3r theta. So theta will be 2 pi minus r over 3r. Then it will be 2 pi minus r over 3. So 2 pi minus 2 over 3, which will come to 1.428 radians. This question, we have a rhombus with 10 centimeter sides, so all 4 sides are the same length. Then the shorter side of the rectangle is 13. Then we can split this and we will find that this is 90 degrees here. We will also realize that this and this is identical. So the radius of the circle is here, which is also 10. So because radius is 10 centimeters, the circumference will be 2 pi r, which is 2 pi times 10 is 20 pi, or 62.8. So we have a slight track down here. We talk about Pythagoras theorem. Pythagoras theorem is used for a right angle triangle. It says that the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. Or in this case, in this diagram, we have h as the hypotenuse. H square will be the sum of a square plus b square. So for all right angle triangles, this is true. So if you want to prove that a triangle is right angle, we also have to do this. So if the two shorter sides add up and then become the square of the longer side, then the triangle is a right angle triangle. So we're gonna use this for this part B. So back to just now, we know like that. So this is 6.5 centimeters. Then we know the hypotenuse is 10. So we will let one of this be h, which also means that this is also h. Then we will find area of one rectangle. We'll find one of this. So there we have a triangle which is 10 and 6.5. So to find h will be h square will be 10 square minus 6.5 square. So h will be 7.59. So area of rectangle is equals to 2 times h times 13. For the next question, there is a need for you to know some angle properties and the different types of angles that are present. Okay, so I have compiled a list that you may find useful. So there are the different types of angles here. We have the acute, right angle, obtuse, reflex. Then you have your supplementary and complementary angles. I'll leave you to read those. Then we have angles like a point, so we have the vertically opposite angles, and then also the sum of angles like a point is 360. Then we have angles related to parallel lines, so we have alternate angles, we have corresponding angles, and we have interior angles. We also have some other properties of triangles that you might want to look at. So one thing to note is all angles in the triangle add up to 180. Then we have also angle properties of quadrilaterals, so trapezium, parallelograms, rectangle and rhombuses, squares and kites, you can read them too. So now the first question, what we want now is to calculate. We know that this is ABCD is a trapezium. We also know AEC is a straight line. Then we want to calculate the reflex angle here. So in order to find the reflex angle, we would need to find the angle inside. So then we will notice there's a Z here. That means this angle and this angle are alternate angles. Then we also notice a straight line here. So this angle plus 45 will give me 180. So when we get So when we get this angle here, then we will be able to get x, then we will be able to get the reflex angle. So we will start with AED. That is 180 minus 45. (135) angles on straight line. Then we can find EAD, which is 180 minus 135 minus 22. That gives me 23. Then this is angle sum of triangle. Then this is 23. Then your BCA will be also 23 because of alternate angles BC parallel to AD. So ABC, which is x, will be 180 minus 23 minus 34. And reflex angle ABC will be 360 minus 123, 237. Angle segment point, and this is angle sum of triangle. Second part down here, we have the line AD, and we are going to use AD as the diameter. Then we draw a circle down here. Then we have to prove that the semicircle does not pass through C. So based on this circle property, if we draw a circle with the diameter like this, then we make two extensions out to the circumference from each side of the diameter. It will form a triangle which has depth as 90 degrees. So in order to prove that it doesn't pass through C, we have to prove that this angle here that is formed is not 90. So we will find ACD is equals to 180 minus 45 minus 38. Angle sum of triangle. So it's 97. So since ACD is not equals to 90 degrees, so by the property of right angle in a semicircle, with AD as the diameter, the C does not pass through, the semicircle does not pass through C. This is how we write it. So then we have other angle properties of circle like this, which is angle at the center equals to twice angle at the circumference. Then we have angle at the same segment, and angles in semicircle equals to 90. Then we have angle properties of cyclic, quadrilateral. So angles in opposite segments are supplementary, that means they add up to 180. Then the exterior angle is equals to the interior opposite angle. So all this you can refer, you can take note. When approaching this question, you must think about the all the angle properties of circles that you have. Then you would try to look at the question and see what they want, and you try to spot how many kinds of properties there are that is given inside the question, and then how many of them can actually help you get useful information for your answer. Okay, so for part 1, we are supposed to find angle ABD. Then we can see a right angle triangle there. Like you see this here, this is a right angle triangle. So we have ABC is a 90 degree. Then because it's right angle in semicircle, so that's one we can find. Then you see that you want the red angle, and the red angle is part of that right angle right now. Then we can also recognize that you have this like that and this like that. So they all are from the two angles are from the same 2 points. So this is 23 because it's angles in same segment. So angle DBC is 23, angle in same segment. So then so ABD here plus the small green one, which is DBC, will give me 90 degrees because it's a right angle. Because ABC is a right angle. So now ABD plus 23 is 90. So ABD is 90 minus 23. Goes to 67. The next part, we want to find EAD, this angle. Then previously we also know that ABC is 90. Then we know this is 23. So I can single out this particular quadrilateral. So then we will know that you have this angle here and this angle here. So AED will be 180 minus 67. So it will be 113 angles in opposite segment. So this is 113. Then we can consider this blue triangle here. Then EAD will be 180 minus 113. We know that angle, and then we know that other ones for it too. So it gives us 25, and this is part of, because of the triangle, so it's angle sum of triangle. So over here we have more properties involving circles. This one involves the chords. So if you have two chords that are of the same length, then the distance to the chords will, from the chords to the center of the circle, will be the same. Then if we have another case where the distance from the chord to the center is the same length, then the two chords should be the same length too. Then if we have a chord and it is a perpendicular, the radius, right, will be the perpendicular bisector. So you end up these two become the same length. Then you have a line that joins the center and the midpoint of the chord. Then that means this two is perpendicular. Then we have more properties involving tangents to circle. So you can have a tangent, and then the tangent is always perpendicular to the radius. So this is 90 degrees. Then if you have tangents and you form triangles to some with the tangent to some external point like this. So the two triangles that form are identical. This triangle and this triangle is identical, so they are congruent triangles. The proof is over there, you can read more about it. Then there is a thing called alternate segment theorem. That means the angle out here is the same as the angle inside the triangle. Same goes for B. So this other part we talk about the conditions of the congruent triangles. So it serves this serves as only a revision, so I'm not going into details. So for congruent triangles, there are a few conditions. One is SSS. That means you show that all three sides of the triangle is the same length. Then you have SAS. That means you have two sides equal and the angle in between is the same. Then you have ASA or AAS. That means you show two angles that are same and one side is the same. So the side should be an included angle in this case. The side should be the included side between two angles, or you will show two angles and one last is one side, like that. Then finally there's this condition called RHS. RHS means you need to have, in these two triangles you must have a right angle and the hypotenuse must be the same and another random side is the same. So since we are familiar with that already, we have a question like this, set up in a similar manner. So they ask you to show that OAT and OBT are congruent. So first you will have, because these two are tangents, so TAO and TBO is equals to 90 because tangent perpendicular to radius. so one down. Then you have AT, now AO is equals to BO. Then second, you have AT is equals to BT, because tangents from external point. Then next you have OT is a common side. So they are the same. So we prove one right angle and then we prove two sides. So triangle OAT is congruent to triangle OBT. Then we label RHS. So then the next part, we have a point P, then it is on the circumference of the circle. So once it's in the and they tell you that the point P, right, the position of point P will allow APT and BPT to be congruent. So it means this point must be kind of in the middle of the two triangles. So one possibility is it may be here. Then you will see that this so APT and BPT, they will look the same because you have common angle, common side, same equal length, and then common side in between. Then the second option could be here, where's P, then you draw. Then same goes, you will have the same side, same length, then you have the same angle. And then there will be one common side down here that is also the same. Okay, before I discuss the next question, I want to kind of bring up some trigo formulas. So in EMAF we have trigo ratios for acute angles. You have your famous what do you call that? Tuakaso, which is our trigo ratios for acute angles. So this is for a right angle triangle. Then we also have the other relation for this that you need to remember. Then again, knowing those ratios, you must know how to find the angles inside the right angle triangle using that. And you also need to know the formulas for the trigo ratios for obtuse angle triangles. And it's quite a popular question. This is quite a popular question in paper 1 that you need to know. Then of course, then we go to the non-right angle triangle, the obtuse angle triangles. You have the sine rule and cosine rule that are used. So you have to know these formulas so that you can work through your question very quickly. So if you have issues with sine rule and cosine rule, we can talk about it. Please PM me, or you can set up an appointment and we'll talk about this in detail. But my whole purpose here is to show the formulas that are required before we do something else. Okay, so this is about circles again with some congruency questions. Okay, so AB is the diameter of the large circle. Then you have CD, which is the diameter of this smaller circle. Then you have AC and BD. These are tangents to the small circle. So we have to show that triangle OAC is congruent to triangle OBD. Mark out the circle. So OAC is this one, and OBD is this one. So show that triangle OAC is congruent to OBD, because we know there are many ways to do it. You have the RHS, you have you have the SAS or the SSS. So we have to work out and see what kind of information that's given by the question. So we know AC and BDs are tangents, so we know that this angle is a right angle. So ACO is equals to BDO equals to 90 degree. So tangent perpendicular to radius. So then, you know, this angle and this angle, AOC is the same as BOD because it's vertically opposite angles. So this is another angle. Then finally, you know CO equals to DO because it's the radius. So it's the radius of the small circle. So since this is an angle, and then this is an angle, and then this is a side, so actually CO and DO is into the side. So therefore triangle OAC is congruent to triangle OBD. Then it's okay, that's part 1. Then part 2, back to this, because they're congruent, then we can easily say that okay, the radius of the large circle is 7. So here to here is 7, and then OAC is 30. So then we are supposed to find the area of triangle AOC. Okay, finding area of triangle, we can have 2 ways to do it. So what A is half times base times height, and the second way is to do half AB sine C. So with the information given, I can't do half times base times height, and I also cannot do half AB sine C because I do not have 2 sides. So the only way we can do it is to use Trigo, isolate this triangle, okay, and find another side. So I would find AC. So if it's AC, then it's here. Then you'll be using cosine 30 equals to adjacent over hypotenuse. So it's AC over 7. So it's this. Then area of OAC is half 6.06 times 7 times sine 30, which is 10.6. Then now we found our area of triangle. Okay, so in this second part, we are supposed to find the area of the shaded area. But previously we have already know that this is 30 degree, this is 90. And the area of this, which is the same as the other triangle, is 10.6088. So I would have to find the length of this CO to find out the area of the smaller circle. So back to this. This is 7, and then this is 30 degrees, so CO8. So sine 30 will be equals to CO over 7. So CO is 7 times sine 30, so it's 3.5. This is 60 degrees. So this and these two add up to 240. So area of shaded region will be area of big circle minus area of sector, smaller sector, minus area of two triangles. So from here, area of big circle is pi 7 squared, minus area of sector is 240 over this times pi, then the radius of small circle is 3.5 squared, then minus 10.6088 times 2. Just give you 107.0641 equals to 107. So the next question requires you to know something about volume and surface area. So I've included the area and volume, the surface area and volume for 3D objects in this that you can refer to. So these are the ones that are required by you. For question 8, this question requires you to find the volume of the barn. So you can see that this shape is a prism, and then we can recall that the volume of prism is the cross-sectional area times the length of the building. So the cross-sectional area is this part, which is made up of two trapeziums. Six, 5. Then you have another trapezium. It's 10, 4, and 6.5. Yeah, like this. So area of trapezium is equals to half times sum of parallel sides times the height. So in this case it will be half times 4 plus 5 times 6, and this one is half times 6.5 plus 4 times 10. The area is this plus this equals to so 79.5. Volume will be 79.5 times 25. Then the second question down here, you need to calculate the total area of the two sloping roofs. So the two sloping roofs will be this one and that one behind. So the one behind will be a rectangle with AG here and 25. Then the red one will be FE and 25. So which means you have to find the length of AD and the length of FE. So you consider this section here. To find FE, we have to single out that section, this triangle. So this will be 2.5 and this side is 10. So via Pythagoras theorem, so this is FE square equals to 2.5 square plus 10 square. So it's 10.3077. Then you have to find AG. AG will be to use this. So you have another triangle here. So this is 1 and this is 6. So AG will be AG square will be 6 square plus 1 square square root 37. So the total area will be root 37 times 25 plus 10.3077 times 25 should be 409.76 410 square root of 3 as so the next section, there's a need to know about angle elevation and angle depression. So we have a diagram here to illustrate what is angle elevation. Means if you have someone who stands at a point a distance off from the tree, and you look at the top of the tree, there's a line of vision down here, and then the angle will be with respect to the horizontal. So this is the angle elevation. Then the angle of depression is the same as the angle of elevation, but it's from a different direction and different perspective. So now we have the same question again. Then we are supposed to find the angle of elevation of P from D. So what happens is you have to let the this point here, and you make this triangle out from that diagram. So the foot of the perpendicular from P, right, we call them X. And this point is the same as this point here. It's a rectangle, so that means there is 10 meters here. So we need to find the angle elevation. We will need to have Px, and we also need to have dx. So Px is the height of the building, so it's 5 plus 1.5, so it's 6.5 meters, which is easily gotten from the diagram. Then dx here is actually like this. X is here and then D is here, so you have 25 and 10 here. So to find dx, you use Pythagoras theorem, which is ex squared equals to 10 squared plus 25 squared. So it's root 725. So dx is root 725 here. Then the height is 6.5. So angle elevation is this angle here, which is this angle. So equals to PDX. So tangent PDX is opposite over adjacent. Then PDX so it's 13.61 dB. In this question we see a circle, then we see a triangle that is bound by chord AB and the radius AON will be. Okay, so then there's a point M there, and chord AB. Then with some revision from the circle properties of circles, with those that's related to the chord, you will know that over here this is a right angle, because the radius would have cut the chord into two equal parts and is perpendicular. So now we have to show that AOB is 96.4 and OM is 20. And another info down here is the radius is 30. So we can break that triangle into two triangles. So I draw this infrared angle here. So 30 and 20. Then the angle we want is this. So we will use your trigo ratios to find that angle down there, because it's a right angle triangle. So cosine AOM is equals to adjacent over hypotenuse. So AOM is which is 48.1897. So this part, one of this is 48 . So because these two angles are exactly identical because they are congruent triangles, so AOB is 48.1897 times 2. 96.38 . Then the second part on here, you are supposed to find the area of the shaded area here. So back to earlier question, we have another one where we have a similar setup. So to find the shaded area, it means that you will have to take the area of the sector minus of area of the triangle, which also is taking the blue area minus the green. So shaded area equals to sector AOB minus triangle AOB. And area of sector is angle, which is just now we found is 96.4 over 360 times pi r squared minus of area of triangle AOB, that means it's half, times 30 times 30 sine 96.4. For 1 pi minus 447,199. So equals to 309.928.310. Then now you have part C. Then part C says the semicircle is a cross section of the water trough of length 1.5 meters. So this is AOB. Then the length of the water trough is 1.5 meter, which is 150 cm. Okay. Then they say find the shaded area represented by the water. So how to find the, so that section here is actually a prism again. So if it's prism, then its volume is cross section area times the length. So cross section area just now was 309.928 times 150. So it's 46489.2. Just 46512 cm. Then the next part, we have to find out, okay, is it calculate the number of liters of water. Number of liters of water that must be added to fill the trough. So that means I have to find the volume of the whole trough that fills up here minus of the original volume of water inside that trough. So volume of water, okay, volume of trough is the cross-sectional area times length. So the length is 150 centimeters. Then the cross-section area is a semicircle, so it's half times pi times r squared. Radius is 30. So this is actually 67500 pi. Then the amount of water to add will be 67500 pi, subtract off 464,892. This is from the previous part. Which gives me 165,568.3041 cm cube, means is 165.568 liters. So from here you must know that 1000 cubic centimeter is 1 liter. So that's how the conversion took place. Then we want to correct the answer to the nearest 10 liters. So it's 170 liter. This part, I am just bringing up the conditions for similar triangles again. So proving similar triangles is kind of similar to the congruent triangles, but then now we must notice that similar triangles, the triangles are not exactly the same, the size is not the same, but the ratio of the sides are the same. So it looks like one triangle is an enlargement or a reduction of the other triangle. So you have the first condition, which is AA. What it means is you have to show that in the two triangles there must be two corresponding angles that are the same. So in this case, this is same as this, and these two angles are the same. Because these two angles are the same, the third angle, the third pair of the angle must be the same. If not, it's not a triangle anymore. So that's AA. Then the second condition that you can have is, again, you see this in congruency, but they say SSS. But now this SSS does not indicate that all sides are the same, all corresponding sides are the same length. This is not the indication. So what it indicates is the corresponding sides are same ratio. That means this corresponds to this, and this corresponds to this, and this corresponds to this. So A divided by X, this pair, is the same as B divided by Y, and is the same as C divided by Z. This is SSS for similar triangles. Then you have this one, which is the, you can think of it as SAS. That means side, angle, and side. So what happens here is, of course, the two sides, the corresponding sides, are not equal. We are referring to the ratio of the two sides are equal, and the angle in between the two sides, right, must be the same. So you call this the included angle. Then that's what's to show that the condition to show that the pair of triangle is similar. So there are also similar plane figures and the relationship to area. So if I have two triangles that are similar, then we can say that the ratio of the sides will be, the square of the ratio of the sides would be the ratio of their areas. So this is what we need to know. Then there's this similar 3D figures. That means the ratio of their masses and their volumes will be equal to the ratio of their lengths to the power of 3. So this is what we need to take note for the next question. So question 10a. We have a pyramid, and then the base is, the sides of the base is 15. Then E is vertically above the center of the square base. So we draw this like that. Then the vertical height of the pyramid is 20. Then we have to show AE. In this case, AE, we have to find a triangle that will fit whatever we want. So I highlighted that, and it gives me a right angle in the center now. So I'll take out that triangle. You see, this is AE and E prime under here. Then the height of the pyramid is 20. Then we would have to find AE. AE is part of the diagonal of the square base. So we have the square base here. Then 15. So AE is actually here. It's half the diagonal. So we will use Pythagoras theorem to find the diagonal. So AC square is equals to 15 square plus 15 square. AC will be 450. So AE square will be half AC, so it's half root 450 square plus the height square 20, which is 22.638, 22.6 shown. So then the second part, we know that AE is 22.6 now. Then we know that this is 20. Then they say calculate BAE. So we will look for the triangle that is involving what we want. So we first have AE, so we want to use that AE. So I'll highlight the AE. Then we want BAE, that means we want this angle here. So the triangle that is involved down there would be triangle BAE. So I draw it out. Then this is 22.6. So because it's a square base, okay, we have a square base, then we can easily say that this one is also an isosceles triangle. Then we want to find BAE. So this angle here, we can use normal trigo ratio. So half of this is 7.5. And since it involves the adjacent and the hypotenuse, like this, 7.5, 22.6 can be calculated. The angle here can be calculated using cosine rule, the cosine ratio. So cosine BAE is equals to 7.5 over 22.6. And 70.618, 70.6 degrees. Okay, this part C, we need to find the surface area of the pyramid. So what I suggest is we draw a net. So that means we open up the pyramid, and then it becomes something like this. So we fill in some information. And there'll be E here, E here, E here, E here. So then we know AE is 22.6. So everywhere else is the same. Every of these sides will be also 22.6. Then we don't know about the height of BAE. We don't know about that. So what we're supposed to do is to find that height. So we isolate it, we have A, E, and let's call this X, like this. So this will be 7.5 and this is 22.6. EX will be Pythagoras theorem. So it will be 22.6 square minus 7.5 squared. So the purpose of this to finding EX is actually so that I can find the area of each of this triangle. So the height of this is 21.32. So to find the total surface area, what I need to do is to find the area of the square plus the 4 of the area of that triangle. So area of the square is 15 times 15, then plus 4 triangles will be half times base 15 times the height 21.32. 8 6 4 point So the last part, we have a small similar pyramid that was being chopped on the top. Then you have the remaining solid below. Then the height here is 4 centimeter. Then they want to find out the top of the area here, So we will take the front view, then I'll flatten it out and then draw front view. Then I have, this is PQ and AB. We know the pyramid is 20, then now the height is left with 4. Then this is 15, and then we don't know what PQ is. So it looks like and it looks like a similar triangle down here, where AEB triangle is similar to triangle PEQ, so then, which means we AB over PQ, let's not do it this way, so PQ over AB will be the same as the height, the ratio of the height, so it will be PQ, so that means it's this triangle, so it's 16 over 20, the height. So PQ is IDK, so 16 over 20 times AB is 15. So PQ is 12. So that face down there will be 12, 12, 12, 12. So area of PQRS will be 12 square equals to 144 square centimeters. If we go to prepare for the next question, we need to revise some curve sketching, graph sketching, graph drawing content. So we have quadratic graphs. They usually look like something like this. Then quadratic equations always start in the format of ax squared plus bx plus c. So if a is positive, then we will have a smiley face like this. So the shape is a smiley face. So it has minimum points. So it has a minimum point smiley face like this. See? So a typical graph will have the minimum point, there will be a line of symmetry, then you have x-intercept, y-intercept. So then there's also mentioned that if the a value is bigger, no, it's smaller, so the graph becomes more wide, is wider horizontally. So this is when a is positive. If a is negative, you have a shape like this and it has a maximum point. So it's a frown face. So it's the same as before. It has the line of symmetry, x-intercept, y-intercept. And the smaller the a, the graph becomes wider. So this is one of the popular questions where they make you do a complete square of a quadratic equation, then after that draw that graph. So if a graph is in the format of x minus p squared plus q, it will have a smiley face because x is positive. The coefficient of x squared is positive. So it will again have a minimum point at p and q, and the line of symmetry is at p. So then the y-intercept will be you inserting 0 in this, and you will get p squared plus q. Of course, if you are given a real equation, you may not need to do it you may not need to memorize all this, you just do as you understand. So then there's a negative x minus p squared plus q. So it is, since x squared is negative, you will get a frown face, and you will still get the maximum point, and you will get the line of symmetry and then the y-intercept. But notice a lot of this kind of complete the square graph, the format complete the square looking graph, they may not have x-intercept at all. So then there's the other kind of quadratic graph, which is in this format, so you have two brackets. So if k is positive, means it's a smiley graph, and then if it's negative, it's frown face again. So the x-intercept usually is, the x-intercept is this and this, and the line of symmetry is your average of a and b. Then there are other standard shapes for graphs that you need to kind of memorize, so that if they give you some other equations, you can just kind of sketch the general shape. Then some more down here, you sometimes have, so sometimes you will have equations where you have y equals to kx plus b plus something, means you shift the graph up by b units. If you have minus b like this, it means you shift down the graph by negative b, shift down by b units. Then, so if you have like say kx cubed plus b, so it's like example down here, you have negative x cubed plus 1. So what you do is you draw the y equals to negative x cubed first, then after that you shift it up by 1. This is how you do the plus and minus. So now our question is this one. So y equals to this. Again, we know the component, so we have the shape, we need to know the shape. We need to know the maximum or minimum point. Then we need to know the line of symmetry. Then the x-intercept, y-intercept. So these are the few things you need to know. So because it's a negative x cubed, negative x squared, so the shape of the graph will be a frown face. So if it's a front face, it will have a maximum point. So how to find the line of symmetry is setting this bracket to 0. So x minus 2 equals to 0, so x equals to 2. The line of symmetry is x equals to 2. Then the maximum point will be when this bracket is 0, so y equals to 9. Then to find the x-intercept, you set y equals to 0. So 0 equals to negative x minus 2 square plus 9. So minus 2 square equals to 9. X minus 2 equals to plus minus 3. So you get x equals to 2 plus 3, 2 minus 3. So it'll be 5 and negative 1. So then, so your line of symmetry is x equals to 2, then like that. So this is negative 1, then this is 5, and then here this is 9, so this is 2, 9. Then we are short of something called the y-intercept. So y-intercept is when x equals to 0. So y equals to negative 0 minus 2 square plus 9. So it's 4. Negative 4 plus 9 is 5. So this point is 5. So on question 12a, we need to find out the scale that is representing this rectangle. So on paper, I measured, on paper when you measure the length of this rectangle is 6 and the breadth or the width is 5 centimeters. So the area of rectangle is 6 times 5 is 30 square centimeters. So given in the question, the actual area of the floor is 19.2. That means 30 square centimeter represents 19.2 square meters. So I want to find out this, what is n. So I will first find out 1 square centimeter. I divide by 30 is how many meters, and I square root it, I'll get 0.8. Yeah. So n will be 0.8 meters. So on the second part, Cheryl decides to varnish the floor in a bedroom. So there were three, the varnish was sold in 3 types, 3 sizes. So then she wants to figure out how much she should buy, so the least amount of money she will need to pay. Okay, for 12b, Cheryl has decided to paint her room, varnish the floor, so she wants to find out the least amount of money she will need to pay for the varnish. And we know that 1 liter of varnish covers 16 square meters. So you know 1 liter of varnish covers 16 square meters. So we need to calculate how many liters she needs. Number of liters equals to 19.2 divided by 16, so she needs 1.2 liters of varnish. Okay, so then the varnish is sold in 3 different sizes. So you have the 250 ml, you have the 500 ml, and then you have the 1 liter. So every one of them come in, okay, so she has to buy so you have to figure out how many tins she needs to buy, and also which tins to buy. So if she were to buy the 50 ml tin, so she buys That means 1 liter 1 liter will cost her 85. But if she were to buy the 1 liter tin, it will cost her 85.95. Then let's talk about this one, the 251. If she buys a liter, it will be 24 times 4. Then you'll be 96. So if she wants to buy 1.2 liters, she will have to buy 2 500 ml ones because it's cheaper, right? Then after that, then she will have to buy 250 ml, right? So that means it will be 420 this times 2 plus 24. Equals to 109. Okay, question 5a here, or 13a. So this is a number pattern question. There is no specific formula that you can do this. I mean, at least in the syllabus you don't have a specific method to do this. You need to observe patterns, so you have to look at the numbers carefully. So they say a rectangular column outlining 4 numbers is shown here. Then they say if t represents the number on the top of the rectangle, so this is t, then find an expression in terms of t for the product of the top and bottom. So find the product for the top and bottom. So I would see 9, 15, 21, 27. So this is plus 6, plus 6, and plus 6. Then from here to here is plus 18. So the last number here, 27, would be t plus t plus 18. So the product would be t plus 18 just to t squared plus 18t. So now back to the second part. This is t, this is t plus 18. So 9, 15, 21, 27, plus 6, plus 6, plus 6. So explain why the difference between the product of the two middle numbers is all, and okay, the product between the two middle numbers and the product of top and bottom is always 72. So the second number here would be t plus 6, and the third number here is t plus 12. So the product of the middle numbers is t plus 6, t plus 12, which will give you t squared plus 18t plus 72. The difference between the middle and the top and bottom is equals to the middle minus top bottom. So it's equals to middle is t squared plus 18 plus 72 minus t squared plus 18. So t here. So it will be 72. So therefore the difference of the number is always 72. Okay, so so now, then just now it said this is t plus 6, then there's another t plus 12, and the last one is t plus 18. They say the rectangular column is placed such that the sum of four number placed is 360. Then they say find the largest number. So you can conclude that it is t plus 6 plus t plus 12 plus t plus 18. Every one of them add up to 360. It's 1, 2, 3, 4. 4t plus 6 plus 12 plus 18. 36 equals to 360. So t will be 360 minus 36 divided by 4. T is 81. So the largest number is 81 plus 18, then it's 99. Okay, 5b. We have a sequence. A sequence means it's a series of numbers. The difference between the consecutive terms is constant. So we can have A, B, C, D, E. So the difference between the consecutive terms are constant, means this is plus x, plus x, plus x, plus x. So assuming this is the third term, and then 4th, 5th, 6th, this is the 6th term. So in front of someone. Okay. So the third term of this sequence is 36. And the 6th term is 60. Then they say find an expression. Okay, find the expression for this sequence. So from the third term to the 6th term, you have actually plus 3x. So 3x is 60 minus 36. So x equals to 8. So then you want the formula, that means you need the first term. So the first term, that means we count backwards. So from 36, the second term will be 36 minus 8. And then the first term will be 36 minus 8 minus 8 equals to 20. So then the nth term, let's say nth term, that means what you do is you take the first term plus a number of terms, then times 8. Because from A to B you plus 8, and then from B to C you plus another 8, and you from C to D you plus another 8. So you just keep on adding. So then you have to figure out the nth term, how many 8s are you going to add. So from the first term to second term you plus. So we examine, so it's 20, then we have 28, then 36, then some numbers, and then times another number, then you get 6, 10 plus 10 becomes 60. So you get 40. You have 44, and then you have 52, like that. So this is the first term. So to go to the sixth term, you plus 1, 8, plus 2, 8, plus 3, 8, plus 4, 8, plus 5, 8. So for first to the sixth term, you plus 5 8s. Okay, so then if you want to go from the first term to the fifth term, you plus 1, plus 2, plus 3, plus 4 of them. To the fifth, you plus 4 8. So it means you come to here, that means if you want n term, you will have to plus n minus 1 of each. So you end up expanding this, you get 12 plus 8n. Okay. Okay, for part 2. So we have to explain why the terms of sequence are all multiples of 4. So remember our nth term just now was 12 plus 8n. So we can take out a common factor 4 down here, so it becomes 3 plus 2n. So from here, n is a integer, positive integer. So the nth term with 3 plus 2n is always a positive number. So then 4 times 3 plus 2n will always be a multiple of 4.